Imagine you're floating through space, a peaceful, endless void. Stars glitter in every direction. Then you spot it, a perfect circle of darkness, warping the light around it like a cosmic lens. You've just found a black hole, and in this journey, you're going in. But what happens when you fall inside might just bend your mind. A black hole isn't a hole in the usual sense. It's what's left behind when a massive star collapses under its own gravity. All that mass crushed into an infinitely small space. The result? Gravity so strong, not even light can escape. That's why it looks completely black. The boundary around it is called the event horizon. Once you cross it, there's no going back. So, you get curious. You drift closer. On the way in, you pass the accretion disk, a swirling ring of gas and dust orbiting at near light speed. It's hotter than the surface of a star, but the black hole itself remains invisible. As you approach, gravity starts to change. Subtle at first, then overwhelming. Your head and feet are pulled at slightly different rates, and that's when it begins. You start to stretch. Scientists call it spaghettification. Imagine being pulled into a giant taffy machine. Your body elongates atom by atom as gravity rips you apart. In a small black hole, this would happen before you even reach the event horizon. But in a supermassive black hole, like the one at the center of our galaxy, the gravity is gentler at the edge. You might cross the horizon without even noticing. But once you're in, the rules begin to change. Time begins to warp. Space twists. To an outside observer, you appear frozen at the edge, forever. But to you, time flows normally. You fall, faster, deeper. You're not just moving through space. You're sinking into the very fabric of the universe. As you continue to fall, time itself begins to behave. Strangely, not for you. Your heart still beats in rhythm. Your thoughts flow as they always have. But if someone were watching from a safe distance, they'd see something else entirely. To them, your fall slows, then stops, just above the event horizon. Your final image hangs there, motionless, forever fading, stretched into red light. It's called gravitational time dilation. The closer you get to a black hole, the slower time moves relative to everything outside. In just seconds of your own time, the universe outside might race ahead by centuries or even more. You might witness the end of stars, the death of galaxies, the universe itself, cooling, darkening, fading. While you, the falling traveler, remain untouched. It's not just a fall into darkness, it's a fall into the future. Strangely, there's no sound, no wind, no fire, just the silence of space and the slow warping of light. Inside the event horizon, all directions point inward. Every path, every option leads to one fate. You're not moving through space anymore. Space itself is moving with you, carrying you toward the center. You try to resist, but resistance is meaningless. There's no direction left to turn that doesn't lead deeper in. Even time has flipped. To you, it still feels normal. But in the language of physics, space and time have traded roles. You're not just heading toward the singularity, you're destined for it, like tomorrow destined to become today. And then there's the center, the singularity, a point of infinite density. No space, no time, no matter as we understand it. Just pure curvature of space-time. The laws of physics stop working here. Einstein's equations divide by zero. Quantum mechanics loses meaning. What actually happens at this point? No one knows. It could be destruction, it could be rebirth. Or maybe there is no center at all. Just a breakdown in our current understanding. Some believe the singularity doesn't even exist in physical form, that it's a mathematical warning. You've gone beyond the limits of what we can describe. Here's where things get even weirder. Physics tells us that information can never be lost. Even if your body's destroyed, the information that made you, your structure, your atoms, your quantum state, must persist somehow. But black holes don't seem to play by those rules. Stephen Hawking proposed that black holes evaporate over unimaginable timescales, releasing tiny amounts of radiation, a process known as Hawking radiation. But that radiation appears random, like noise. So what happened to the blueprint of you? Is it erased? That's the black hole information paradox, and it's one of the deepest mysteries in modern physics. Some scientists think your information is stored on the event horizon itself, like a cosmic USB stick. Others believe it's smeared into the Hawking radiation, encoded in ways we don't yet understand. And a few even believe that your fall creates a duplicate version of you, one inside and one outside, splitting reality as we know it. If true, black holes might not be cosmic prisons, but cosmic archives. But what if falling into a black hole doesn't mean destruction, but transportation? Some theoretical physicists suggest that a singularity might be connected to another region of space via a wormhole, a shortcut through the universe. If that's true, then the center of a black hole could lead somewhere else entirely. A parallel universe? Another time? A mirrored version of our own cosmos? We don't know. But in some solutions to Einstein's equations, it's mathematically possible. Of course, wormholes might be unstable. They might collapse instantly. But maybe, just maybe, they're real. And someone, somewhere, might already have gone through. If you enjoyed this journey into the unknown, don't forget to like the video, subscribe for more mind-bending space stories, and hit the bell so you never miss what's next beyond the stars. Thanks for watching, and stay curious.